Remember that in the beginning there was light, water and a circadian rhythm. Think about that for a minute, especially when I go on and talk about how mitochondria work. And also remember that none of this is medical or health advice. It's just me talking about what I do to stay healthy, energetic, and live a long time based on the scientific literature, of which I'll put the 2 papers I'm going to discuss today in the notes under the video. This information I provide on these videos is not a replacement for health advice from your own health professional. As you know, I'm still currently, after nearly 6 years, suspended from nutritional and environmental medicine practice. So what I talk about is what I do, and my interpretation of the scientific literature only. Shouldn't replace professional advice from your own health or medical practitioner. Also, I've trained long and hard to be able to get in Finnish fire saunas and icy cold water. So don't attempt that without discussing it with your own health professional, or do some training in it as well. We're going to talk about 2 fascinating studies. One study on the mitochondria and its their relationship to cancer, and the second study on vitamin D and how it relates to the immune system. At the moment, I'm dodging flies out of Lake Mundara in the Queensland outback. This is a man-made lake to supply water for the nearby town. Now, it is supposedly full of freshwater crocodiles, and even though I live in Australia now, traditionally I'm from New Zealand, and us Kiwis have a very healthy respect for large dinosaurs called crocodiles. Now, they can be freshwater ones, the locals called freshies, and saltwater ones, they're called salties. Apparently the freshwater ones, and perhaps I shouldn't be walking quite close to the waterline, no normal New Zealander would ever do this. Apparently the freshies are okay unless you stand on them. Salties though, you want to stay well away from them. And you'll also notice that I'm out walking at sunset. Actually, that becomes relevant later on in the story when we'll talk about melatonin. So what I'm doing at the moment is the infrared light, the red light from the sunset is starting to trigger the release of melatonin from my pineal glands and from my mitochondria. That'll become relevant later on. So let's start off with talking about quickly what mitochondria are. So mitochondria are organelles inside our cells. We have about 1 quadrillion of them in our body, and the theory is that they originated billions of years ago from an endosymbiotic event where one bacteria engulfs another one, because mitochondria are thought to be ancient bacteria living in our cells which have lost some of their DNA. Now the interesting thing about mitochondria is that everybody knows they produce energy in the form of ATP. So how do they do that? Well, what goes into mitochondria is electrons from food. So food is basically a source of electrons for the mitochondria. How does that food get into the mitochondria? Well, it's pumped in by thyroid hormone and B vitamins. So it's kind of like a coal-fired steam engine on a train. Somebody's there got to be shoveling coal into the engine to burn, to produce the steam to power the engine. And it's thyroid hormone and B vitamins which pump the food into the cell, which then get converted into electrons which pass through the mitochondria. So what do mitochondria do with those electrons as they pass through the electron transport chain? Well, they convert it into energy as ATP. They turn it into heat, which is why I get in cold water to exercise my mitochondria. They turn it into exhaust fumes, i.e. free radicals. They also turn it into light and water. So just remember what I said at the start. In the beginning, there was light, water, and circadian rhythm, and the energy which created them. Think about that for a minute. So that's what mitochondria do. They produce energy, light and water, which is relevant to our story. Well, what about cancer? What do we think that cancer is? Well, most of the evidence suggests that cancer is a mutation in one of our cells created by a toxic environment. It's kind of like the cell's defense mechanism against the toxicity. It mutates in a desperate effort for survival, and it also starts to reproduce and spread, like it wants to prolong the survival of the mutated species that it's turned into. So we also know that probably 50% of those mutations inside the cell occur in the mitochondria, so which has its own DNA which is separate to us. So basically cancer is a mutation of our cells in its desperate attempt to survive a toxic environment. Now fortunately our bodies have a defense system to fight against cancer, prevent it from spreading and growing. And most of that defense system is the immune system. How does that immune system power itself? Well, it powers itself, like anything in our body, from ATP from mitochondria. So that's the relationship between cancer cells and mitochondria. So for the cancer to survive, it has to do something about the body's defense mechanisms, which is the environment around the cancer cell that it has to grow in, and the immune system. So how does cancer protect itself from the microenvironment and the immune system? Well, it does that in several ways. First of all, it changes the microenvironment. It changes the way it metabolizes and produces its own energy, and it also damages and sabotages the immune system. Those are called tumor invading lymphocytes. And what we now know, according to this study, is that the mutation of the mitochondria gets into the lymphocytes, and it does that in two ways. The cancer cells join up with the lymphocytes and form vesicles and microtubules, which transfers the mutations from the mitochondria into the DNA of the immune cells, and eventually all of those immune cells become full of just the mutated DNA, so they get to change sides. So in summary, in order for the cancer to succeed, it has to change its environment, has to change its metabolism, and it has to cause dysfunction in our immune cells by inserting its mutated DNA into the T cells, the tumor infiltrative macrophages, in order to cause dysfunction in those cells. Okay, so what can I do about that? Well, interestingly, just a quick crocodile scan, interestingly, the body has a way of removing damaged, dysfunctional mitochondria, and that's called mitophagy. And so what I try and do is, obviously I try and keep my environment as toxic free as possible, but I also try to encourage mitophagy, so those damaged mitochondria are removed as quickly as possible to try and prevent dysfunction in my immune system defenses. So what's responsible for mitophagy? Well, I call it the 2 C's and the 3 M's. 2C, 3M. 2 C's are cold thermogenesis, because we know cold thermogenesis makes more healthy mitochondria, but it also has a role in removing damaged mitochondria. It's also coenzyme Q10. Coenzyme Q10 is a mitochondrial nutrient which assists electron transfer through the electron transport chain in the mitochondria, creating more energy for us. It also mops up some of the pollution caused by the combustion of the mitochondria, and also has a role in mitophagy. What about the 3 M's? Well, the first one, of course, is melatonin, which I'm now stimulating the release of from my pineal gland and my mitochondria, because melatonin has a huge role in mitophagy. Then there's my old favorite, magnesium, which has a big role in mitophagy, also absolutely essential for optimal mitochondrial function. Mitochondria magnesium dependent for their optimal functioning. And the last one is methylene blue. So in summary, we've got coenzyme Q10, we've got cold thermogenesis, we've got methylene blue, melatonin and magnesium, which I use to optimize my mitophagy, so I get rid of damaged mitochondria as quickly as possible, so other cells can't hijack them and convert them into completely different mutated cells. Right, let's move on from mitochondria to one of my other favorite subjects, which is vitamin D and sunlight. And really the vitamin D story really begins in the late 1800s, when people start to work out that both sunlight exposure and consumption of cod liver oil help prevent infections and also bone weakness diseases like rickets. Chapter 2 is kind of the early 1900s, when Florence Nightingale and others discover that putting patients with infections like leprosy and tuberculosis out in the sunlight or opening windows in ICU seemed to help the infections quite a bit. Shortly after that, the vitamin D molecule is isolated and discovered. Then, chapter 3, 1929, Alexander Fleming discovers penicillin, a mold growing on an agar plate of bacteria. And then penicillin comes into the story again in 1941, when it's first used intravenously during the Second World War. So after 1950, all our research went into antibiotics after the discovery of penicillin, and vitamin D fell into the, oh, it's good for strong bones, but not much else. That was, of course, until a recent viral problem, when there's now been over 2,000 studies on the use of vitamin D in the immune system. First of all, we'll talk about what vitamin D is. So vitamin D comes from cholesterol. Cholesterol in our blood, and exposed to sunlight in our skin, gets converted to cholecalciferol, and in our liver it gets converted to 25 hydroxy cholecalciferol, and then our kidneys, in fact, guess what? In the mitochondria of our kidneys, it gets converted to active vitamin D, which is 1,25 hydroxy vitamin D. Now here's what I find really interestingly. We used to think that was the only pathway, but now, well, in my opinion, because this is not medical advice, but you can read a bit in the articles I've attached, is that vitamin D is now known to be an autocoid, which means it's produced locally by the immune system in small amounts, which is very powerful. So an autocoid is defined as, can I go this way? An autocoid is something which is a substance was produced locally, which in small amounts, which has a very powerful effect. So vitamin D also known to be produced locally in areas that's really needed, which is why I try and get sunlight on as much of my body as I can. So what does vitamin D do about viruses? Well, vitamin D disrupts the viral membrane. It also, once the virus gets into our cells, it also stops the virus replicating, and it also reduces release of the virus from our cells. Now, here's the really interesting thing. We know from a certain viral pandemic recently that the way that virus got into our cells was it used its protein, called the spike protein, to attach to receptors on our cells called ACE, angiotensin converting enzyme receptors. And that was the key that unlocked the cell to allow the virus to get inside us. Now, the really interesting thing about vitamin D as well is it's been shown to increase levels of CAMP. CAMP is cathelicidin antimicrobial peptide. And what CAMP does is not only it tears viruses apart, but it also, guess what, stops the spike protein from binding to the ACE receptor. So it kind of sits on top of the ACE receptor and stops the spike protein of a certain virus attaching to the the lock which allows it to get into the cell. So in summary, vitamin D, not only really good for strong bones, but also is very antimicrobial, including bacteria, fungi, and specifically in terms of viruses, it damages the cell membrane, stops them replicating inside the cell, it stops them being released, and it increases CAMP levels, getting very close to the water's edge now. How's the sunset going? Increases CAMP levels, which sit on top of the ACE receptor and stop the spike protein from attaching to the lock which allows it into the cell. Woo. So that's it from me and all my friends, the freshies and the countless brown snakes I've probably narrowly missed on the walk out here today. Please remember, I can't give any medical health advice. I'm just a crazy dude hanging out with freshwater crocodiles and brown snakes, talking about the crazy things he does to keep healthy and full of energy. If you want to check the things I've said, you can check the 2 research papers I've attached to the video. And of course, I talked about one of my favorite quotes on the last video from Lone Survivor. The other one I like, also from Marcus Luttrell, where he says at the end of the movie, "Brave men have fought and died, building a proud tradition and fair of reputation that I am bound to uphold." Thanks for watching. Share and like the video if you have found it useful. I'm going to sit here and watch the sun go down completely, really boost my melatonin levels, and I'll catch you in a couple of days with the next video. Thanks for watching. Love you all. Bye. Oh, and I thought I'd just say, as a safety tip from an emergency physician, if you ever are walking in the Australian outback and you do have the absolute misfortune of being bitten by a brown snake, make sure you've always got a phone with you, because you don't want to be walking after you've been bitten. You want to lie still as possible, wrap the affected limb in a compression bandage and call for help, because it's very important that you try and minimize the spread of that venom until you get an emergency department and get tested to see if you actually have been envenomated. So, always a good idea in any wilderness situation to have emergency communication, of course, but particularly so in the Australian outback, full of creatures that will kill you. So you can don't have to walk if you've been possibly envenomated, can stop the spread of the venom until you can get evacuated to an emergency department where you can be tested to see if you have been envenomed or not. On that cheery note from the Australian outback, just trying to find the road now. See you next time, I hope.